Welcome to Formnext 2023 and welcome back to our industry stage here in Hall 11D72. And welcome to our Expert Insight final show keynote. Yeah, it's very sad, but we are coming to an end with Formnext 2023. But we have prepared a highlight for you. And that highlight, you know, when the fair is coming finally to an end, we will have a kind of a wrap up. I know it's impossible, but we want to cover most of the topics and have an outlook. And we prepared that outlook, not I, not we. Dr. Wildrich Heising, come to me on stage. He prepared the outlook for us. Dr. Wildrich Heising is partner and associate director of Boston Consulting Group, BCG, and he will show how distributed manufacturing is empowered by 3D printing, and he will give us some outlooks in the market, and we are very happy to have you here, and we are very happy that the stage is now yours.
Thank you very much. Hello, good afternoon. Thanks for being here, and I have to say I'm energized by the last 4 days of Formnext that are behind us. When we walk the halls, we can feel the power of innovation in additive manufacturing. The themes that I've seen over those past days were basically sustainability. So there's quite a significant element on sustainable production and how additive manufacturing can make a difference in bringing sustainable manufacturing forward. Then there was a notion on automation. So we have seen quite some automation elements at this Formnext. And last but not least, the topic of quality is one that I think is very important. When you look at the parts and the development of those parts over the last years, the ones that we have now in our hand are much more reliable and have a much higher quality than the parts that we had in our hands a couple of years back. And now my talk is about how we can take that power of innovation, how we can take that power of quality and reliability towards the next stage, towards manufacturing, and how we can make a difference in additive manufacturing or with additive manufacturing in manufacturing, distributed manufacturing. My name is Wildrich Heising. I'm a partner and associate director with the Boston Consulting Group. Joined some 17 years ago. I'm fully focused on operations topics and have the honor to lead our additive manufacturing unit within BCG. With my team together, I've conducted probably 60, 70, 80 projects along the entire additive manufacturing value chain, and that allowed me to form a perspective on additive manufacturing as such, the market, the growth that we see there, and the trends. And today I would like to speak about 3 topics. The first one is understanding the market and the growth potential that we see in also the current environments in additive manufacturing. We'll look into unlocking manufacturing applications at scale. So how can we make that transition work from prototyping to manufacturing and then serial manufacturing applications? And then we speak about the role of distributed manufacturing. So how distributed additive manufacturing can make a difference here as well in supply chains. So looking at the market, we can say that we are at the verge of industrialization. Today we are rather niche market, roughly 18 billion. Over the next decade, we'll grow to roughly $95 billion all in. That is material, printers, and service business associated with that. In the end state, we are speaking about an opportunity of 300 to 350 billion so quite a significant market. Of course, that growth creates also disruptive dynamics. And first of all, when we look at that graph, we see that while the growth rates are having come down quite significantly from those prosperous times a couple of years back when we were envisaging growth rates of 30% or more per year, basically for additive manufacturing, this has come down and is now more realistic. We also see that additive manufacturing will not crowd out traditional manufacturing. It will be in the end state roughly 1 to 2% of the total take rate of the total manufacturing market. So rather small, but in substance, another tool in the arsenal of manufacturing technologies of the users of the technology. we are facing some headwinds in additive manufacturing, and there's no need to dress that up and to make it look shiny and prosperous. But there's some significant headwinds that we face. We had a peak of, we had a series of over-evaluation in the market roughly in 2021, also driven by a lot of IPOs. So a couple of companies went public. These rates have come down to more sustainable levels now. When we look into what happened there, then on that slide, rather busy actually, we see a lot of change, a lot of movement, and a lot of actually going public of a couple of companies. But also what we see today is that we are facing a period of consolidation. While in the last years, the ecosystem grew and grew and grew, we are now at a stage where actually some of the players go together. And actually what we see is that there is a consolidation trend towards or around the equipment manufacturers. I mean, you probably have followed the news around Stratasys and over the summer with a lot of different merger and acquisition elements floating around. So what we see is basically a consolidation trend in the industry. But that can also help us in order to basically then grow from that consolidated space, because what we need in additive manufacturing are standards and common grounds and common solutions to drive forward and to scale additive manufacturing. Looking now into manufacturing, the manufacturing element, what I mentioned before. So while prototyping, of course, is still a very important use case for additive manufacturing, we now need to make sure that we make that transition towards manufacturing, that we go that process and all the steps that go with that to make sure that we produce end-use parts and that we are able to bring additive manufacturing to the shop floor factories in tooling and production parts to make sure that we can really scale additive manufacturing. Of course, that transition is a key challenge for OEMs, for example, to deal with that. And I think one thing that we need to really think through when we speak about bringing additive manufacturing towards serial production is to really think through where the user of the technology is today and where we can help him or her. And often our focus is a bit too narrow when we just look at the individual part and when we compare two parts, traditionally manufactured, additively manufactured, but we need to think a bit broader, because at the end of the day, the user of the technology, when we are speaking about production environment, they don't really care about the technology. They care about a problem or a challenge being solved. And we as an AM community need to rethink the way how we approach the end users of the technology. We need to help them to identify how our solutions that we bring to the table can make a difference for their challenge that they have. And here I brought a couple of value drivers that we can think through when speaking with users of the technology. So first of all, of course, there could be direct savings when we compare traditional manufacturing and additive manufacturing. But that's not the predominant use case. Often additive manufacturing can even be more expensive, and you all know that, when we do a direct replacement of a part, for example. But another use case which is very important is capacity increase. So earlier this year, I was supporting a project for a large US company in the electric component business, and they have a multitude of roughly 400,000 different SKUs in their portfolio. So massive complexity, and they had the problem that they were totally maxed out in their factories. So they were using their production lines also for low runners, where you just had a batch size of 200, 300 and so on and so forth. And that, of course, meant that when you have a low runner on the production line, you need to do some changeover, and that all loses time. That brings down your efficiency quite significantly. And here for that client, actually, it really didn't matter whether the part was double the price when we do it in additive. The key unlock for value was here that we could free up capacity while taking those low runner volumes into additive manufacturing and focusing the high runner products on their traditional manufacturing machines. Also on the supply chain resilience, I'll come to that in a minute when we speak about the second part, the distributed manufacturing element. So with 3D printing, we can really make our supply chains more resilient, and that is a key thing, especially when we have the last 3 years of disruptions that we are constantly facing on our radar. Then that can be a really unlock and a value unlock. Also inventory reduction or improved lead times, logistics savings, AM-enabled design changes, and last but not least, also ESG benefits, so sustainability as one of the key things that we can drive forward with additive manufacturing. So in a nutshell, when we think about manufacturing use cases, we need to think broader. We need to take the perspective of the user. We need to help him with his or her with the challenges at hand and bring a solution to the table. Let's double click basically into those value drivers and how we can translate these value drivers and potential and possible use cases at manufacturing companies. So looking at the current portfolio, low volume products, custom-made products like engineered to order and so on could be relevant. Slow-moving products could be moved to additive manufacturing. Products that currently create a negative margin in your traditional manufacturing could be also a possibility to rethink with additive manufacturing. And backlog products, when you have multi-step processes where you can bring together multiple production steps that also, create complexity in your manufacturing environment, that we can bring together and simplify basically the setup, how we produce those parts, they can make a difference here, or here we can make a difference with additive manufacturing. Double-clicking on that example of the capacity increase from traditional manufacturing, just to make that a bit clearer what I meant with that, where it helps when moving low runner or low volume series away from traditional manufacturing and finding an additive solution for that. So what we see here in a very simplified version is on the left-hand side, the amount of time that we have basically on a traditional manufacturing machine when we produce a low volume series, for example, batch size of 100. So of the 100% of time that is available for that, roughly 25% is actually production time and 75% is basically the setup time. So you lose quite some capacity that you have. And in a situation where you're over capacity, where you don't have any capacity left, that is of course horrible as a scenario from a manufacturer's perspective. So by taking out basically these low runner volumes and doing low runner volumes with additive manufacturing and doing the high runner volumes only on the traditional manufacturing machines, we can actually change that relation quite significantly. So we can change that to 75% of productive time and just 25% of setup time. So that means we can actually create 3 times more products in the same amount of time than before. So that is where it starts to become very, very interesting for traditional manufacturers. And here in that example of that American company that I mentioned before, we could actually identify a value potential of $100 million basically by moving some of the traditional volume that is produced on traditional machines to additive manufacturing. And the key driver for that value was not that additive manufacturing is cheaper, but it's they could produce much more of the other high margin stuff on their high runner product lines. So that's what I meant with we need to change the perspective a little bit. We need to understand what are the real pressures and needs of the users to help them with our additive manufacturing solutions. But unlocking growth in additive manufacturing really requires to rethink how we offer AM and how we address the user. While the early adopters of the technology were willing to experiment, they were willing to try out materials, designs, and printers, and those printers were one size fits all. That doesn't work in a manufacturing environment. In a manufacturing environment, we need to provide a solution that just works. Yeah? So with a high level of first time right and reliability. Our additive manufacturing systems must be able to be integrated into the production environment with a high level of manufacturing readiness. So we need to think about manufacturing execution systems and how we can integrate that into basically the factory shop floor. And we need to have dedicated solutions for specific problems of the users. The one size fits all doesn't work anymore. And then there's another element that I want to double down on now is the possibility to go into distributed manufacturing that can open completely new areas and new avenues. So, I mean, we all realize that the world around us is getting more and more complex. We are facing supply chain disruptions. We are facing increasing geopolitical uncertainty, climate net zero commitments that are postulated. We have a huge pressure on cost and margins at the moment. Digitalization and Gen AI is in everybody's mouth. We face a significant labor and talent shortage. There are regulatory changes all around the world, and also, last but not least, changing consumer behavior that we need to face somehow. So, in a nutshell, supply chain management is getting very complex those days. So, distributed manufacturing can actually be a puzzle piece in that complexity and to bring some remedies to that complexity. So when I speak about distributed manufacturing, I speak about three different facets of distribution. So one of all is geographical distribution. That is very obvious. Basically, you produce the same or a similar product at multiple locations in your network. Instead of having one factory, you might have 3, 4, 5, 6, 7 factories around the world. You can also think about distribution in a sense that you can distribute over time. So instead of producing batches and then another batch, you can also realize a batch size of 1, or basically produce exact the same the quantities that you need on demand, basically. And then we can also think about distribution across the value chain. So you don't need to be basically the manufacturer that necessarily, or the company that necessarily owns the design. You can also leverage basically third parties or hybrid manufacturing models and distribute basically the work content over several parties. But however, in the past, these distributed manufacturing had limitations. So think about utilization, and we've seen on the slide before with the graph that low utilization can actually quite harm manufacturing. So in a distributed production setup, you will have lower capacity or lower utilization of your capacity. Change over time will hurt your production efficiency with an increased amount of changeover runs and short production runs. And then also qualification and regulatory concerns are quite significant that you need to consider when you basically spread your production around. However, 3D printing now can really help to address the limitations of general distributed manufacturing. First of all, additive manufacturing is a highly integrated and digital process. So additive manufacturing allows a fully digital process and fully digital interactions between the different parties. For example, between the producer or the design owner and the one who's actually then making the part. Moreover, additive manufacturing is quite cost competitive at low volumes, and we have seen that before. And we are also seeing an expanding global production network with a lot of service providers around the world that have necessary qualifications, that can cope with regulatory environments, and so on and so forth. I want to make that point here that distributed additive manufacturing can really make supply chains more sustainable, more resilient, and they can reduce cost. I have 3 examples here on basically reducing emissions and scrap. EOS and Umavo, you might heard about those classes. I wear some of those basically, where with additive manufacturing you're able to reduce the scrap by 58% and can quite significantly increase basically the sustainable manufacturing approach to manufacturing. On the resilience side, Danfoss is an example. Within the COVID or during the COVID pandemics, their supply chain basically broke down in some of the elements. So they were able with 3D printing to qualify parts in very short time, and were then able to open up their supply chain again and drive resilient production forward. And then we are able, of course, to boost profits and generate revenue with additive manufacturing. Replique and Siena Garden is one example of where you have a online storage and an online platform where you can store your spare parts. You can decrease your inventory holding costs quite significantly, can have the spare parts on demand, and as such generate new revenue streams that were not there before, actually. With that, I'm coming to an end. So the key takeaways of today's discussion are basically that distributed additive manufacturing is on the rise. Manufacturing use cases can be a major unlock, and actually must be a major unlock in order to enhance our additive manufacturing ecosystem. We would see the market roughly going to 95 billion in the next decade, And in the end game, we are speaking about some 300 to 350 as an overall potential in additive manufacturing. So still quite interesting, but we need to make sure that we unlock value for the users in manufacturing scenarios. And we have discussed multiple levers, how to do those. And then companies can improve their value proposition, strengthen their operational resilience, pursue sustainability ambitions through leveraging distributed additive manufacturing. With that, I'm at the end of my talk. So just if you're interested in further reading, BCG has been one of the first to actually also note the transformational power of additive manufacturing in the consulting world. A couple of publications can be found online. And if you have any questions, please shoot them now or come back to me at a later point in time. Reach me via LinkedIn, email. Very happy to get your questions. Thank you very much.
Thank you very much, Wilderich. An applause for Wilderich, please. Yes, thank you very much. The question tool is quite interesting because we have a Slido tool as well, and I have opened it right now, but there are no questions from our audience. They are all tired from 1 week of exhibition. But I have some questions for you because I was wondering, you brought to us very interesting examples, but you mentioned the importance of standards. It was just as one sentence, one side sentence. With more standards, I understood we can accelerate the growth. How do you have an idea how much faster we could reach our milestones in growth when we would have standards today?
Yeah. So let me bring an example from actually one of the cases that I've just done. So a manufacturer wanted to define which is the right additive manufacturing system / material combination for his use case. And then he was looking into several different printers and he got very quickly very confused about what actually at the end they will produce, will provide. Is he able to switch things or not? Because we don't have that common ground necessarily in all the dimensions yet. So having a standardized way how we approach additive manufacturing would make it easier for the user to also switch, and that alone the idea of being able to switch will actually bring down the barrier and will bring down the hurdle for that additive manufacturing. So I think working on standards, creating a community where people come together and different players in the industry come together and think through what could be a good standard going forward, I think is helpful. I mean, we see a lot of those elements going on today, but I think we need to accelerate that.
Yeah, it's hard work. It's hard work to create these standards because the community is so diversified. We had some medicine here on stage, and they have already certifications for the whole process, from the machine over the process to the materials and so on. But when I understood you right, we need it from your perspective. We need it for mostly or all the processes and machines and materials.
Indeed.
And who would it be to create these standards?
That's a good question, actually.
Yeah,
it's not an easy question.
We will solve that next year in 2024 here. But I have another question, maybe very demanding. You mentioned that you have a worldwide outlook as well. You might know that we have the partner country Australia next year. Do you have an impression about the AM community, how big it is in Australia? Maybe you remember it, or is it a too demanding ask?
So actually, not quite sure how much it is.
I feared it because when we look over there, left to our booth, there is the Formnext international network, and so all the countries and all the areas are so busy with doing business. But maybe you bring next year some numbers concerning the Australian market. I would be very glad to see you here again.
Thank you very much.
Thank you very much, Wilderich, for being with us and for sharing your insights. And if you here at the booth want to make contact with Wilderich, just grab him here before the exhibition is over. And if you want to make contact with Wilderich, you find the slides in the recording of his presentation in the Formnext media library, where you can have a look at all what we produced here on stage after the exhibition. So keep calm, you can do it next week. Thank you very much. Here, one applause, and thank you very much at our audience and live stream and here at the booth. We will be back in some minutes with our after work talks.